one here. This stuff's going through the point estimate, margin and error, and 90% confidence interval for the following case for example 1. So here we have the average age of 30 first-year students at a particular college is 20 years old with a standard deviation of 0.7. And here we're assuming that this data is normally distributed. So first of all, if we're talking about our point estimate here, what we're really talking about is how we're estimating the population mean in this case, because here we're talking about an average. Remember, another name for the average is our mean. So if we're estimating our mean, we're going to use the sample mean. So here in this case, our sample mean, we symbolize as x bar, just like we've done before. And that's going to be equal to 20. So that's what it says is the average age of these 30 students. So our mean here is 20. That's our point estimate. And then margin of error, we normally abbreviate here. We can either do it as MOE for margin of error, or in the book here we have E, represents our margin of error, capital E. And the formula for this is we have to do the z-score that corresponds to our confidence level, which in this case we had was 90%. That's what it gave us in the problem up above. And then we have to do that times our standard error, which we talked about at the end of chapter 5 before, which is our standard deviation divided by the square root of n. So in this particular case, if we look in the normal distribution table, you'll notice at the bottom part of the negative side of your normal distribution on page A16, or if you're looking in the back fold out part, it'd be on the negative side. There's a part that says critical values at the bottom there. So it has it for a few different levels of significance. The 90% one is one of them. So if we look there, our z sub c, the z-score value that goes along with a 90% confidence level, is 1.645. So put that down here. And then we have to multiply that times the standard deviation, which is 0.7 here, divided by the square root of n, which is 30 in this case. And then it's a matter of going through and calculating here. You want to go at least 2 decimal places, so whenever you're rounding here again, so we get approximately 0.21 if we calculate that out there. So that's it for the margin of error part. And then the confidence interval, what you do for that is you kind of combine together that point estimate and the margin of error. So to write this out, you can write it out as an interval. Intervals have the parentheses that we're putting the values into. You put the smaller value first, so we do that point estimate minus the margin of error. So the smaller number first, comma, and then the bigger number. Because intervals, you start with smaller to larger, just like on a number line. So you do your point estimate minus the margin of error, and point estimate plus the margin of error. So in this case, for our confidence interval here, we have, it goes from 19.79 up to 20.21. The confidence interval here, what this means is that we'd expect for our population mean to be between 19.79 and 20.21 in about 90% of our samples, hence this 90% confidence interval. So here, this part here, I'm going to abbreviate. This was our confidence interval. I'll put CI for confidence interval to remind you of that here. And that gives us the interval of values that we would expect our population mean to fall between in about 90% of our samples. So not in all of them, but in about 90% of them. Depending on the confidence level, of course, depends on what your interval is going to be, how wide it's going to be there. For the second one here, we have how many students would need to be surveyed in order to be 95% confident that the sample mean is within 5 years of the population mean age for those students at the college and a standard deviation of 0.7. So what I did here, I wanted to change this value first of all because otherwise we got a small value for n. I'm going to make it so it's a little bit bigger here. I noticed it after I set this up. Let's change the 5 years to a half of a year. So that way we get a value for n that's more than 1 here. And the formula that we use here to estimate what our n would have to be for the sample size is this one here. So we still use the z sub c, the value that you can look up in the table there, times your standard deviation over the margin of error, and then you square all of that. So in this particular case here, for a 95% level, if you look that up in the critical values table at the bottom of your normal distribution table, we get 1.96 there, times the standard deviation, which is 0.7 in this case, divided by, and in this case I had switched this so the sample mean is within 1/2 of a year. So if it's within a certain amount, that's also your margin of error. That's just another way of stating your margin of error there. If it's within a certain amount. So it tells you how far away from that mean you can go above and below for the margin of error. So here, if we calculate that out here, we get approximately 7.53. And in general, kind of like we had to do towards the beginning of the semester here, in order for it to be a large enough sample size, what we want to do is then use n as being 8. So here we'd want to round up for all of these, because otherwise, if you had 7 here for the sample size, it wouldn't be large enough to cover this entire interval for this margin of error of 1/2. So whenever you're finding the sample size, you can round up for your final answer there if it's not already a whole number.